Hi, everybody. This is me, Mrs. Pesic, wanting to give you some tips on how to do the 1.7 gifts. All right, so first of all, let's get familiar with the first gift. The first gift, which I'm calling Gift A, is really just problem 9 on page 72, which is one of your homework problems. So I'm trying to help you out by making this problem 9, all right, from page 72 and putting all of this on a piece of paper for you. So you don't have to use all of that graph paper. You can just use the Gift A. All right, so it says for the directions, use the graph of F to sketch each graph and write the new ordered pairs by each of the 4 key points on your new function. All right, describe the transformation for each new equation. So for this first one, remember this is number 9 from your homework, and it is letter A. All right, and so what we are doing is we are going to look at the parent, identify the parent function. Well, the parent function is just this function that we see here that's drawn. That's going to be the parent function for all of these problems for number 9. All right, so first of all, we need to identify what is this transformation here. And in this case, the transformation is, we see the negative, so it's a reflection. It's a reflection over the y-axis because that the negative is in with the x, so it's a reflection over the y-axis. So we want to take each ordered pair, like let's start with this -4, 2. We got to take each of these ordered pairs and reflect over the y-axis. Well, if I want to reflect that point over the y-axis, it's going to end up over here at 4, 2. All right, so I'm going to put that point, -4, 2 is going to end up over here at 4, 2. Notice what's happening is the x was made negative, and so I need to take the opposite of every x, and that's going to reflect it over the y-axis. Likewise, if I take this ordered pair -2, 2, and I reflect that over the x-axis, that's going to be over here at +2, 2, and I'm going to write the ordered pair by it. I'm sorry, +2, -2. All right, so that's our next ordered pair. And then 0, 2 is not going anywhere, so that's staying right there. And then this ordered pair, 6, 2, is going to get reflected over to -6, 2 over here. All right, so that's -6, 2. So now we're just going to connect those points. So that's going to be 4, 2 gets connected to 2, -2 gets connected to 0. -2 gets connected all the way out here to -6, 2. And you can hopefully see that this is a reflection of the original over the y-axis. All right, let's take a look at, well, let's just do letter B. We're just going to do a couple of these together so you understand what you're doing for your homework. So in this one, if I've got y equaling f of x plus 4, we're going to take that same parent function and we're going to add 4 to every f of x value. That means we're adding 4 to every y, which means we are shifting this whole graph up 4 units. That's the transformation that you're going to list. And now we're going to write our ordered pairs. So the -4, 2 is going to become 1, 2, 3, 4 is going to become up here at -4, 6. We are adding 4 to every y coordinate. So -2, -2 is going to become -2, +2. 0, -2 is going to become 0, +2, and 6, 2 is going to become 6, 6. All right, and now when we connect these ordered pairs together, we are going to get this shape, and I strongly suggest that you use, a straight edge for this. Yours will end up looking neater than mine, I'm sure, but this, we can see now, that looks like it's been shifted up 4 units. So that's how you do these problems, and you're going to identify every transformation. Now for this one, this is letter D, just to point out, you really have 2 different transformations. You've got a transformation because you've got x minus 4. Remember, since I'm adding or subtracting, that means it's a shift, left, right, up, or down. Since it's in with the x, that means it's a shift to the right. All right, so this is a shift right 4. okay? And because we see this negative out in front, that's a reflection over the x-axis. Reflection over the x-axis. All right, so if I shift all of these points to the right, all these points to the right 4, negative 4, 2 becomes 0, 2. Negative 2 becomes 2, negative 2. 0, negative 2 becomes 4, negative 2. And 6, 2 becomes 10, 2. So far, I'm going to draw this one in, but this is not our final answer. That's just shifting to the right 4. Okay, and I could write those order pairs next to it. That might help us out here. So that's 0, 2. This is 2, negative 2. This point is 4, negative 2. And this one is 10, comma 2. But now that we've done that, we want to reflect over the x-axis. So if we're going to reflect over the x, that means this point 0, 2 is going to end up down here at 0, negative 2. What's happening? If we're reflecting over the x-axis, all of the y coordinates get made opposite. So instead of 0, 2, we've got 0, negative 2. Instead of 2, negative 2, we're going to have 2, positive 2. 2, comma, positive 2. And instead of 4, negative 2, we're going to have 4, positive 2. I'm trying to write all these in. And instead of 10, 2, we're going to be down here at 10, comma, negative 2. So connecting these up, it looks like I have this segment going like this, and then over here like this, and then down here like this. So this graph, this final graph here, this is our final. Make it a little bit bolder. That is our final graph, and that's the result of shifting 4 units to the right and then reflecting over the x-axis. Okay, by the way, we definitely want to do the shifting to the right first, because picture that you were going to plug in some number in for x, well, you would end up subtracting by 4 first, then plugging that value into the function, and then the last thing you would do would be take the opposite of that. All right, so that's how you do gift A, which again is just problem number 9 from your homework from the book. Let's take a look at, this is 1.7 gift B. In this case, it says identify the parent function and all transformations, then sketch the graph without using a calculator, and then you may check your graph with your calculator. Graph by hand first before reaching for your calculator. All right. So in this first example, number 1, I think that if we're looking at 2 times x minus 3 quantity squared plus 1, I think we can identify that the parent function f of x would just be the x squared function. All right. And then just to remind everybody what the x squared function looks like, it goes through 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. Hopefully you have a really good idea about this and that that's your parent function. All right. But we want to graph this function. All right. And so again, first thing I notice is we've got an x minus 3. That's a shift to the right 3. So if I can, I am just going to try and shift this whole graph 1, 2, 3 units to the right. All right, and then notice that I'm multiplying by 2. So if I'm multiplying by 2, that means it's a, let's see, I didn't write shift right 3. Let me write that down. This is a shift because of this. Let's see, I'm going to get rid of this line and that little scribble there. All right, so what I want you to notice is that this x plus 3 here means a shift right 3. Okay. And then I've got this 2 out in front, and that 2 is going to mean a vertical stretch of 2. All right, so that means from this point, let me slide this back over here. I'm sliding this here, and my transformed point, as I said, is going to be shifted over 3. 1, 2, 3. So that's here, here, over here and over here. So here's the shift right 3. Shift right, that's supposed to be a 3 there, right? Okay, and now we want to do a vertical stretch. So in order to do that, I think hopefully you are going to notice that we would want to take all of these y coordinates and make them twice as high. Well, 0, 0 is still going to be right there, but not 0, 0, but 3, 0 is still going to be there. But 4, 1 is now going to be at 4, 3, and 5, I guess this is 5, 4, is going to be at 5, 8. 3, 1 is now going to be at 3. I messed up. Let's see. Let me move this point down because 1, 2, 3, 4, 1 is going to be at 4, 2. I think I said 4, 3. And then 1, 2, 3, 4, 5. 4 is now going to be at 5, 8. And 2, 1 is going to be at 2, 2. So I need a point. Let me have the point, please. Oh, it's not going to let me. At 2, 2, we're going to have a point, and at 1, instead of 1, 4, we're going to be at 1, 8. So that means the graph is now looking like this. Should be a little curvier than what I'm doing. Shouldn't look quite that much like a V, but that's the general idea. We can see it's been vertically stretched. It's looking narrower, and then that's because of this 2, and now because of this plus 1 at the end. Let's see, let me do this color. So because of the plus 1 at the end, that means that we are adding 1 to all of the y coordinates. So really, we're taking this whole graph, and we're sliding it up 1. Except mine got messed up. So if I'm going to slide this whole graph up 1, instead of 1, 2, 3, 0, I'm going to have 3, 1. Instead of 4, 2, I'm going to have 4, 3. Instead of 5, 8, I'm going to have 5, 9, and so on. So this point is going to be here, and let's see, this point is going to be up here. So now my graph is going to look like this. All right, something like that. So it's been shifted to the right 3, it's been vertically stretched, and I didn't write this down, but it's been shifted up 1 unit. All right. Okay, so that's how you do problem number 1 from B. And let's see if there's anything else did we follow all the directions? I think so, except we didn't check it with the calculator, but I'll let you do that. Let's see, and maybe we should do one more of these together. Let's try number 4. So with number 4, the parent function is f of x equaling square root of x, and with that, hopefully you know that square root of x goes through 0, 0, 1, 1, square root of 4 is 2, the square root of 9 is 3, and so we're getting this as our parent function. All right, and now I see again 3 transformations that I'm going to have to identify. Right here I see a 2 that's being multiplied by the x. So is that a shift, a stretch, a compression, a reflection? Well, it's not going to be a shift because we're multiplying. It's not going to be a reflection because we're not taking the opposite, at least not right here with the 2x, but we're multiplying, which means it's going to be a stretch or a compression. Since the 2 is being multiplied just by the x itself, that means it is a, let me see, get rid of that, switching colors here. So that means it's going to be a horizontal stretch or compression. And with that means that it's going to be a horizontal something, but if it's a horizontal stretch or compression, we really need the reciprocal of the 2. So it's going to be horizontal something of 1/2. And because that last number is less than 1, that means it's going to be a horizontal compression of 1/2. All right, in order to graph a horizontal compression of 1/2, all of the points all the x coordinates need to get multiplied by 1/2. So we had 0, 0, but if I multiply that x by 1/2, I'm still at 0, 0. All right, so that's still right here, okay? And then I've got to take the ordered pair 1, 1 and multiply the x coordinate by 1/2. So that's going to give me 1/2 comma 1, which is right there. All right, and then instead of 4, 2, which was on the original, I'm going to have to multiply that x by 1/2, so that's going to be 2, 2, that's right there. And so what we're going to end up seeing is our graph is going to look something like this. All right, it's rising up a little bit steeper. It's looking, you know, a little bit like it's been pulled in towards the x-axis. That's a horizontal pulled in towards the y-axis, which means it's a horizontal compression of 1/2. All right, now we have this negative out in front, and with this negative, that's going to be a reflection. So you're going to identify that. That's a reflection over the x-axis. So I want to take all of my ordered pairs and take the y coordinates and switch them from positive to negative or negative to positive. So that means I'm going to have 0, 0, and then instead of 1/2 comma 1, I'm going to have 1/2 comma negative 1. And instead of 2 comma 2, I'm going to have 2 comma negative 2, and so on. And so that graph is going to look something like this. That's been reflected now over the x-axis. And then the last thing we need to do is to shift it up 3. So if I shift this whole thing up 3, every order pair gets moved up 3 points. That one gets moved up, let's see, 1, 2, 3. That one gets moved up 3. This one was at 2, 2. So now it's going to end up at 2, negative 2, I should say. And now it's going to end up at 2, negative 1, and so on. So that graph, the final graph, is going to look something like this. There's our final graph. All right. All right, and let's confirm this with our calculator just to make sure we're doing okay. Okay, so let's take a look at this graph on our calculators. We are going to graph opposite of square root of 2x plus 3. So I'm on a graphs page, opposite of square root of x, I'm sorry, square root of 2x, and then a right click, and then plus 3. I think that was the equation that we were graphing. Looks correct, and there it is. And hopefully you're seeing a similarity between that and you know, what we drew together. All right, and let's see, is there anything else, other directions that we were supposed to do with this? Sketch without using a calculator, check your graph with your calculator, and we just did that. Okay, so then if we get to problem like number 5, it says write the function that matches the graph shown. After you've written down your answer, you may check your answer with your calculator. Well, first of all, I hope that you're noticing that this is definitely an x squared function for number 5. So we know we're going to be working with f of x equaling x squared. All right, and if it's f of x equaling x squared, but it looks like it's been, you know, reflected over, it's not opening up, right? Instead, it's opening down, so it looks like it has been like reflected over the x-axis. So instead of writing f of x equaling x squared, we're going to want opposite of x squared, right? Because if we want to reflect it over the x, we've got to put a negative out in front of the whole function. But I also noticed that it has been shifted. It looks like it has been shifted, you know, like 1 unit to the left. So if that's the case, then we need to go right in, let's see, we need to go right into the x itself, and we need to add 1. All right, so it should be opposite of x plus 1 quantity squared. I think that should do it, but I do want to check on one thing, and that's just, all right, there is something more to this that we have not picked up on yet. So let's take a look, and that is that we're not quite done. And why do I say that? Because our true function, which I kind of have this true function here, it's not the best. Let me get rid of that one. That one is going away. So let me get a better function. Notice our true parent function goes through 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4, and so on. So it looks like this. All right, but that means when I reflect it, even if I have, you know, this as my vertex here, if I don't have any stretching or compressing, it should still go, you know, to the right 1, down 1, to the right 2, down 1, 2, 3, 4, right? And so on. And this is definitely not doing that. It's not letting me draw a point there. I don't know why. Anyway, let's see. So if I have this point here, so in other words, to me, this graph that they gave us looks wider than the parent function. Well, remember, it can look wider for one of two different reasons. It can look wider because it's been horizontally stretched, or it can look wider because it's been vertically compressed. And in this case, you really can't tell just by looking at the graph. So instead, though, what I think I would like to do is to figure this out is just compare some ordered pairs here. So if I have like this ordered pair, and let's see, if I went over 1, and I should be down 1, but it looks like I'm only down like 1/2. And if I go over to the right 2, I should be down 1, 2, 3, 4. It should be here, but instead of being at 4 units down, I'm only at 2 units down. So that, I think, tells me that this graph has been vertically compressed by a factor of 1/2. So, for example, let's just write down what some of these ordered pairs are here. Get rid of that point. So some of these ordered pairs, what do we have on here? We've got 1, -2. We've got our vertex here is at -1, 0. And I think I see another one that's at -1, 2, 3, -3, -2. So if I'm right about this, then we're going to need to throw a 1/2 in front of this function. So we are going to need, I don't know if that's very neat, but we're going to need, erase this, start again. Let's see, erasing, making this a little neater. So we are going to need to squeeze in, I think, the 1/2 in front of the function, and we still need that negative. So I think this should be our graph, our equation, I should say, for this graph. And I think we should test this. All right, so we're going to go to our calculator, and I am going to try to get this graph to look like this, and not only look like this, but go through -1, 0, 1, -2, and -3, -2. So testing this out, I want to add a page to my document, and I'll call this like 1.7 homework, something like that. I could add a notes page to say, hey, this is gift B number 5 or whatever it is. So here I want negative, and I said 1/2, so control divided by 1/2, and then I thought it should be x, I'm shifting to the left, so x plus 1 and quantity squared. All right, that's what I get. It sure looks like the right function, but let's pull up a table and see if it actually matches some of the ordered pairs that we saw. So control T, and if I look, I'm looking for what were the ordered pairs I saw on the graph that they gave us. -1, 0, -3, 2. Let's see, -1, oh, -1 goes to 0, -3, that's what I meant, -3, -2. And then the other point that we're looking for is 1, -2, and sure enough, 1 does go to -2. So I think we have it. I think that answer is correct for this one. All right, so I will let you, wrestle with these. These are kind of fun. I don't think, for 7 and 8, I don't think I did any kind of a vertical stretch or compression or horizontal stretch and compression. I think that these are all shifts and reflections for 7 and 8, just to give you that hint. All right, let's take a look at number 9. It says, write an equation for the function that is described by the given characteristics. The shape of f of x equals x squared, but moved 3 units up and then reflected over the x-axis. So if we want to have the shape of f of x equaling x squared, but moved up 3, I'm just going to do kind of my work over here while I'm thinking about this. If I want that moved up 3, then, let's see, get rid of that. So I want x squared, then plus 3, right, to shift it up 3. But then I want it reflected, and then reflected over the x-axis, which means we need to make the whole function negative, right? So I got to put a negative in front of the whole thing. All right, so that is what we should see for this. And you could test this out, but I'll write this as g of x equals opposite of x squared plus 3. All right, and if we try, let's see, let's see, I'm going to go on to gift C just to practice a few of these. So for gift C, it says, describe the transformations necessary to transform the graph of f of x into that of g of x. Try to make a prediction first, then check your prediction with your calculator. So if square root of x is our parent function, then what effect would it be if I have square root of x plus 1? So I hope that you're recognizing that that's going to be a shift, because it's something's being added or subtracted, and it's going to be a shift to the left one. And so that's what you kind of write for these. Each one of these, I think, is just a single transformation. Yep, looks like it for all of these. Notice, I mean, these, number 9, number 10, very important. These are the reflections, but you need to understand the difference between having a negative outside the square root and having a negative inside the square root. So think about what kind of transformation that would be. And of course, you can check these on your calculator. Again, this is going to be a very important page 13, 14, 15, and 16. I mean, I see two of them, 13 and 15, have the number on the outside of the function, all right? And 14 and 15 have the number in with the x. But notice that these are all being multiplied. So it's not shifts and it's not reflections. Instead, these are all stretches or compressions, all right? I would say these two here, because the number's on the outside, these are going to be your vertical stretches and compressions. And these two here, because the number was in with the x, are going to be your horizontal stretches or compressions. So that's my hint for you on those. And then for number 17, it says sketch the graph of each function. So I do want you to do these on graph paper, all right? So sketch doesn't mean, hey, just grab your calculator and type it in. This is you sketching this on graph paper. So, and of course, I'm not pulling out my graph paper just because I'm doing just a quick job with you right now, but you're doing it on graph paper. So remember, if my parent function is square root of x, then it goes through 0, 0, 1, 1, 1, 2, 3, 4, 4, 2, and so on. So my parent function is going to look kind of like this. But with this, x minus 1, that's going to shift this whole graph. That's going to shift this whole graph to the, boy, that's not what I wanted to happen. Whole graph 1 unit to the right. So that was not too bad. That shifted it just about 1 unit to the right. And then it's going to shift it 3 units up. Right? I'm shifting everything up, but you get the idea. So this is a square root, shifted 1 unit to the right, 3 units up. And you're going to graph that on graph paper. All right. Again, for these, sketch the graph, describe the parent function. So the parent function here for this one would just be our absolute value of x. And as you know, the absolute value of x looks like a V shape. Okay. And then we want to shift it 3 units to the left, 1, 2, 3, and then up 1, up 1 unit. So something like that should be our final graph. But again, graph paper is key here. All right, so you got to use graph paper. Graph paper, right? By all means, check your answers on your calculator. Notice number 20 really has 3 transformations. You got the x plus 1 that you got to deal with, you've got the opposite that you got to deal with, and you got this minus 1 here. All right. Then for 23 and 24, it says transform the given function f of x as described and write the resulting function as an equation. So this time, instead of giving you a transformed equation like we had in like 17 and 18 and 19 and 20, this time they're telling you what the parent function is and then telling you how you want the transformation to be, and you have to write the equation. So for example, with number 23, if I want to stretch this function vertically by a factor of 2, I got to multiply the whole function by 2. All right, and then I also want to translate it right 2 units, which means then I need to go in and subtract 2 from the x. So I think that this would be our final answer here for this one. All right, and that's the kind of thing that you're going to do with these problems. All right. And let's see, let's take a look at 27. This one, identify the parent function and write an equation. So this time you're given a graph and you've got to write the equation. Hopefully you're recognizing for number 27 that this is absolute value of x. All right, and notice the absolute value of x would normally start at 0, 0, go through 1, 1, 2, 2, 3, 3, 4, 4, right? It's just a V shape right here. So what's happened to this V? It looks to me like this V has shifted to the right maybe 2 units and down 1. Well, let's write that out. That's a shift. That's a shift right 2 units. It's supposed to say right 2 units and down 1 unit. So if I take my parent function, f of x equaling square root of x, and I want to shift it right 2, then I'm going to have x, absolute value of x minus 2, and then I want to go down 1, so I'm going to need a minus 1 out in front. So again, you can check that on your graphing calculator to make sure that looks good. All right, and that's it for this video. I think that hopefully will get you started on doing these problems, and thanks for watching.